Hello, curious minds. Today we embark on an extraordinary journey through time to uncover the incredible story of our planet. How did Earth form? Where did the continents and oceans come from? And most importantly, how did life begin? Get ready, because this tale is nothing short of astonishing. Our story begins over 4.5 billion years ago in the vastness of space. A swirling cloud of gas and dust collapsed under its own gravity, giving birth to our sun. The remaining material began to collide and merge, forming planetesimals, small, celestial bodies that eventually coalesced into planets. One of these young planets was Earth, a molten sphere of chaos and fire. But Earth's formation was far from peaceful. Violent asteroid impacts bombarded its surface, reshaping the young planet. One colossal collision changed everything. The impact with Theia, a Mars-sized celestial body. This cataclysmic event not only melted large portions of Earth's crust, but also ejected debris into space, which eventually coalesced to form our moon. This event helped stabilize Earth's orbit and set the stage for the next chapter of its evolution. At first, Earth was a seething ocean of magma, but as it cooled, solid rock formations began to emerge. The first continents started forming through a process called differentiation, where heavier elements sank to the core while lighter materials rose to the surface. One of the key pieces of evidence for Earth's early land masses comes from a type of rock called amphibolite. Scientists have discovered 4.28 billion-year-old amphibolite rocks in Canada, meaning that just 200 million years after Earth formed, the first solid land had already begun to appear. But here's the real shocker. Chemical analysis of these ancient rocks reveals that liquid water existed on Earth at that time. This raises an even bigger question: where did all this water come from? For decades, scientists have debated whether Earth's water originated from within the planet itself or was delivered from space. One of the strongest pieces of evidence supporting the latter theory comes from meteorites. A meteorite that crashed onto Earth 35 years ago contained salt crystals with tiny water droplets inside, evidence that water may have been carried to Earth by asteroids and comets. Another clue lies in banded iron formations, layers of iron-rich rock that suggest ancient oceans existed billions of years ago. So, did our planet's oceans form naturally, or did they arrive from space? The answer may be a combination of both. Either way, water was present, and that meant life had a chance to emerge. With Earth now covered in vast oceans and solid land masses, another mystery remained. How did life begin? The key ingredient: amino acids, the building blocks of proteins and ultimately life itself. In 1969, a meteorite that crashed in Mexico contained amino acids, proving that these essential molecules can form in space and potentially be delivered to planets. This discovery revolutionized our understanding of life's origins. But even with amino acids, something was missing: oxygen. At that time, Earth's atmosphere was a toxic mixture of carbon dioxide, sulfur, and nitrogen, completely unbreathable for modern life. So how did we get the oxygen we rely on today? The answer lies in some of the oldest life forms on Earth: stromatolites. Around 3.5 billion years ago, stromatolites, structures built by cyanobacteria, began performing photosynthesis, converting sunlight and carbon dioxide into oxygen. For millions of years, these microorganisms pumped vast amounts of oxygen into Earth's atmosphere, triggering what scientists call the Great Oxygenation Event. This was a turning point. Oxygen not only transformed Earth's atmosphere, but also paved the way for complex life to evolve. It was a slow process, taking billions of years, but it ultimately led to the explosion of diverse life forms that we see today. Despite all we've learned, some questions remain. How did simple organic molecules transition into self-replicating life? Scientists have proposed many theories, from the famous Miller-Urey experiment, which simulated early Earth conditions and produced amino acids, to the RNA world hypothesis, which suggests RNA came before DNA and played a crucial role in the emergence of life. Other theories include the deep-sea hydrothermal vent hypothesis, which suggests that life may have originated in the nutrient-rich environment of deep-sea vents, and even the possibility that life didn't start on Earth at all, but was seeded from space. a concept known as panspermia. Earth's story is one of constant transformation, chaos, and adaptation. Science is continuously uncovering new clues about our planet's past, reshaping our understanding of where we came from. And perhaps the most important lesson we can take from this journey is this: curiosity is the key to discovery. So, keep questioning, keep exploring, and never stop learning. And as always, stay curious.